Merlin Machinery Incorporated, based in Somerville, Massachusetts, introduces the range of soldering, tinning, and scaning machines manufactured by Pillar House Limited of Essex, England. Pillar House is located in southeast England, near the city of Chelmsford, Essex, which is approximately 60 miles from the heart of London. The company was formed in 1978 and has grown to become a leading manufacturer of wire scanning and component soldering machines. Merlin Machinery Incorporated is the North American representative for Pillar House Limited. We handle sales, service, and engineering support and spare parts from our location in Somerville, Massachusetts. Merlin Machinery was formed specifically to handle the North American market for Pillar House, and this is the sole function of the company. Our range of equipment includes magnet wire scanning machines, component soldering machines for a wide variety of applications, tinning machines for leaded components or surface mount devices, and soldering stations which can be adapted to special purpose machines. Shown here is the Omicron machine, which can be used for soldering or tinning applications. The machine consists of a 4-position rotary table, which is loaded at one station and then indexes to present the parts to a flux station and then a soldering station. The fourth station is available for optional testing or unloading. An automatic turnover device is available which will rotate the tooling at the flux and solder stations so that components with terminals or leads on opposite sides can be processed in one pass through the machine. Also shown here is the tester unit, which is checking these components for continuity. A resistance test unit can also be connected into the Omicron machine circuitry. The fluxing station is fitted with a pump, which continually recirculates the flux to ensure a consistent mix and maintain correct level. A flow control is also fitted to adjust for flux wave height. The soldering station consists of a pump, which provides a constant supply of dross-free solder at the nozzle. The tooling is pushed down onto mechanical stops, and dwell time is programmable. This ensures that the depth of immersion is very accurate. A unique feature of the Omicron machine is the burst mechanism. During indexing, the solder flow will increase. This ensures that any residues from previous operations are removed from the surface of the solder wave. As shown here, tooling is interchangeable. Simply push down on a release lever, remove the fixture, and replace it with a new one. The tooling adapters, or slaves, which fit into the machine are available separately so that customers can manufacture their own custom tooling. A locking mechanism is also provided, which will prevent the tooling from being removed if this is required for your particular application. To change the depth of solder immersion, simply remove the stop screw assembly and replace it with a preset one, which is set up for your new tooling. Shown here, the stop at the soldering station is being changed. There is another assembly at the fluxer station. There are various types of wave shapes available so that a variety of components can be run on the same machine. These nozzles can be designed so that solder can be directed into areas which have restricted solder access. Components which cannot normally be dipped into a flat wave can then be handled automatically. Shown here is a version of the Omicron, which has a fully automatic load and unload unit to process components on pallets. This system can be integrated into a production line by transferring the pallets onto conveyors. The components are picked up from the pallets at the position where an operator would normally sit. And after the turret is indexed, the finished component is located back into its pallet, which then advances to present the next component. This pallet system is ideally suited to RM coils, or parts of a similar configuration. The turnover mechanism can also be used so that the machine can process transformers or other components with terminals at opposite ends of the coil. This system can also be fitted with a return conveyor, which will take the completed pallets back to their starting location. Using this setup, the conveyor can be situated alongside a winding machine, so that the operator would unload the wound coils directly onto the pallets and then simply unload soldered coils from the returning pallets. In order to handle other components, the conveyor unit will accept different pallets which are designed to suit the new parts. Shown here is a variety of pallets to suit different size RM coils. This version of the Omicron has a vacuum fixture for holding flat components. In this case, surface-mounted devices can be tinned. The parts are loaded onto a platform, and the tooling has a vacuum device which picks up the components off of the platform for tinning. After the components are tinned, the vacuum is released, which automatically drops the parts into a discharge chute. Tooling is also available which will handle leaded devices which need to be tinned. Various levels of automation are available, from simple hand loading to fully automatic detaping to taping applications. This fixture is for manual loading of axial components. The parts are held between two plates and the fixture is rotated manually before the turret is indexed. After the tinning operation, the parts are returned to the operator. The fixtures can be rotated 180 degrees manually if the automatic turnover device is not incorporated. Pillar House is the recognized leader in magnet wire